solving systems of equations by addition. This photo is Oak Alley Plantation in Vatry, Louisiana. The photo was taken by Elizabeth Kelly in 2007. To use this technique, we start with two linear equations in standard form. ax plus by equals c. If the terms in the problem are not in this order, start by rearranging the equations so that the terms are in this order. In this discussion, when we use the word coefficient, we are talking about the number beside each variable. 5x minus 3y equals 18. The coefficient of x is 5. The coefficient of y is negative 3. Let's look at some examples of how this method works. 1. Our equations are 2x plus 3y equals 3 and 5x minus 3y equals 18. We notice that the coefficients of y are the same number but with opposite signs. We have a plus 3y and a negative 3y. We can add the equations together and the y terms cancel out. We put one equation under the other and add the two equations together. In this case, we get 7x equals 21 because a positive 3y and a negative 3y cancel out. Since both sides of an equation are equal, we are really adding the same thing to both sides of the equation. Now in this case, we divide by 7 and we get x equals 3, which is the first part of our answer. Now we substitute our first answer into one of the equations to solve for the second variable. In this case, we might as well use the second equation because that's where we have the most room on our paper. We substitute x equals 3 and get 5 times 3 minus 3y equals 18, or 15 minus 3y equals 18. We subtract 15 and get negative 3y equals 3, and divide by negative 3 to get y equals negative 1. Now we have both parts of our answer, but we are not finished yet. We always have to check. There are too many steps to neglect checking our answer. We check in the equation that we did not use last. So here we check in the equation 2x plus 3y equals 3, because that is not the one we finished with. We get 2 times 3 plus 3 times negative 1 equals 3. Or 6 plus negative 3 equals 3. 3 equals 3. So now we know we have the correct answer. X equals 3 and y equals negative 1. This is called the addition method. It is also sometimes called the elimination method because you start by eliminating one of the variables. Let's look at a few more examples. Example 2. Our equations are 4x minus 2y equals negative 2 and 4x plus 3y equals 23. This time, the coefficients of the x terms are the same, but we need them to have opposite signs. We multiply one of the equations by -1 to change the sign of each term in the equation before we add the equations together. So now the first equation becomes -4x plus 2y equals +2. We add the equations together and get 5y equals 25. Then dividing by 5, we get y equals 5. Now we substitute our first answer into one of the equations to solve for the second variable. In this case, we have plenty of room under the first equation, so we'll work right there. We substitute y equals 5 and get 4x minus 2 times 5 equals -2. 4x minus 10 equals -2. We add 10 to both sides and get 4x equals 8. And divide by 4 to get x equals 2. We still have to check. Check in the equation that you did not use last. In this case, we use the first equation last to find our second answer. So we want to check in the other equation. So our check is 4 times 2 plus 3 times 5 equals 23. 8 plus 15 equals 23, or 23 equals 23. So we know we have the correct answers. In our third example, our equations are 5x minus 4y equals 8 and 3x plus 2y equals 7. We are looking for coefficients that match but have opposite signs. We don't see any that match, but if we multiply the second equation by 2, then the y coefficients would match and have opposite sign. So we multiply the second equation by 2, and we have to multiply every term in the second equation by 2. We get 6x plus 4y equals 14. And now the y coefficients match and have opposite sign. Now we can add the equations together, and the y terms will cancel out. When we add the equations together, we get 11x equals 22. Divide by 11, and we get x equals 2. Now we substitute our first answer into one of the original equations to solve for the second variable. It really does not matter which equation we use. By substituting into the second equation, I get 3 times 2 plus 2y equals 7. 6 plus 2y equals 7. Subtracting 6, I get 2y equals 1, or y equals 1/2. So this time our answer is a fraction, but we are not afraid of fractions. In the equation that we did not use last, which in this case would be the first equation. So we get 5 times 2 minus 4 times 1/2 equals 8. 10 minus 2 equals 8, because half of 4 is 2, or 8 equals 8. Once again, we are confident that we have the correct answer. In this example, we had to change one of the equations before we could add to eliminate a variable. In our last example, we will change both equations before adding. In example 4, our equations are 2x plus 3y equals 11 and 3x minus 5y equals negative 31. In this problem, we can choose which variable to eliminate. Since x has the smallest coefficients, we will eliminate x by multiplying to get the least common multiple of 2 and 3. The least common multiple of 2 and 3 is 6, so we'll multiply the first equation by 3 and get 6x plus 9y equals 33, and we'll multiply the second equation by 2 to get 6x minus 10y equals negative 62. If necessary, change the signs in one equation and then add the equations together to eliminate the first variable. Here we change the signs in the second equation to get negative 6x plus 10y equals positive 62. We add the equations together. The x terms cancel out and we get 19y equals 95. Now we divide both sides by 19, if necessary using scratch paper or our calculator, and get y equals 5. We substitute our first answer into one of the original equations to solve for the second variable. Here we substitute y equals 5 into the second equation and get 3x minus 5 times 5 equals negative 31. 3x minus 25 equals negative 31. Since it's a minus 25, we'll add 25 to both sides, getting 3x equals negative 6, and we divide by 3 to get x equals negative 2. But we're not quite finished. We check in the equation that we did not just use recently. So we're going to check in our first equation here, and we get 2 times negative 2 plus 3 times 5 equals 11. Multiplying, we get negative 4 plus 15 equals 11, or 11 equals 11. So our answers check. The steps for solving equations by addition are: 1. Look for a variable with matching coefficients that have opposite signs. If necessary, multiply one or both equations by constants so that one of the variables does have matching coefficients with opposite signs. Step 3. Add the equations to eliminate a variable, then solve for the remaining variable. Using your first answer, substitute into either equation and solve for the variable that you eliminated. And finally, step 5, check in the equation that you did not use last. When should we solve by addition? The addition method works for linear equations in standard form. The addition method is best when we cannot easily solve for one of the variables to use substitution.